Hi, everyone. I'm sorry I couldn't be there in person today, but I am excited to share with you the results of the 2024 USGS forage fish surveys on Lake Michigan. So today's talk will focus on three surveys conducted in 2024. I'll begin with a summary of the spring bottom trawl survey, including the rationale behind the last several years of work, the overall study design in 2024, and then some high-level results. I'll then review the design and results of our two annual surveys, the hydroacoustic survey and the fall bottom trawl. And when applicable, I'll also make some comparisons between these surveys and the spring bottom trawl that was implemented this year. We have conducted the spring bottom trawl in some form since 2021, with the overall goal of determining if it provides a more comparable estimate of yearling and older alewife to the acoustic survey than our long-term fall bottom trawl survey. This is in response to a continued difference in estimates starting around 2014 between the acoustic survey and the fall bottom trawl, where the acoustic survey is continuously representing higher densities overall. So our primary question is, has some specific change to the fall resulted in lower catchability in the bottom trawl survey? And if so, could sampling in the spring, when it's hypothesized that alewife are aggregated in about 100 to 200 meters in water or at these greater depths outside our normal range of study, we might have a more comparable density estimate than the fall bottom trawl survey. So going into 2024, we had observed in the previous three seasons that alewife do appear to be aggregated in these deep waters in the spring, and we have seen slightly higher biomass density estimates than in the fall. However, we've only been able to have one complete full lake survey prior to 2024 in the spring, so we were excited to enter this field season with no staffing or vessel limitations. The spring bottom trawl survey in 2024 mirrored the design of the 2022 survey. So it was conducted at 6 ports where we had 60 tows between 9 and 237 meters in depth. So this actually included 45% of those toads greater than 110 meters, so outside the range of our historical fall survey. Again, trying to target those alewife in those deep water habitats we expect them to be aggregated in for overwintering. Now in 2022, we actually had a later start date, and in 2024, we pushed the start date up 10 days to April 9th. This was because we had a very warm winter, and we wanted to make sure we were actually capturing these fish while they were still in their deep water habitats. And we were actually able to complete the southern portion of the survey at Saugatuck all the way over to Waukegan by April 15th. Jumping right into the major results from this survey, overall preyfish density was 5.7 kilograms per hectare, and this primarily consisted of deep water sculpin in the highest densities, followed by bloater, alewife, and goby. We also captured several lake trout as well as a lake whitefish during the survey. Again, results were similar to what we've seen in 2021 to 2023, and that alewife densities were highest in these deep habitats, so seemingly still occupying these overwintering habitats in the deep portions of Lake Michigan. In fact, 6 tows were between 110 and 200 meters in depth, had densities greater than 5 kilograms per hectare, so some pretty large catches. Overall, alewife biomass, when we estimated this across the lake, was 1.30 kilograms per hectare. So we were interested to see how this value compared to what we saw in the fall and hydroacoustic surveys. Additionally, we aged 603 alewife, and thanks to Patty Dieter and Steve Farha at the Great Lakes Science Center for leading that effort, and 95% of these were actually age 1. So this is very similar to what we've seen in the previous 3 seasons, where the predominant catch in the spring is yearling fish. Through the talk, we're going to periodically return to the spring survey results as we compare them to the 2 annual surveys, but we're going to jump into those designs here. So the hydroacoustic survey consisted of 24 transects over 468 kilometers across Lake Michigan. This was again a collaborative effort between the USGS, Michigan DNR, and the U.S. Fish and Wildlife Service. Paired with these hydroacoustic surveys were 38 midwater tows to address species composition. The fall forage assessment, shown here by the black dots on the right, consisted of 83 tows. 11 of these are what we consider deep water or outside the range in which we estimate biomass historically, between 128 and 164 meters. We conducted these tows to try to have some comparisons to what we were able to do in the spring. This is actually the most tows we've been able to conduct for the fall forage assessment, largely due to great weather and a really committed crew this year. Alewife from both of these surveys have been aged already. There were 212 from the fall forage assessment and 227 from the acoustic survey. So we're going to jump right into the results, and we're going to first focus on the 3 species that are estimated in both of these surveys. That would be alewife, then bloater, and rainbow smelt. Then we'll talk about some of the other fishes in the fall forage assessment that we assess using that survey. So here we have the catch of yearling and older alewife from the hydroacoustic survey on the left and the fall bottom trawl on the right. In the hydroacoustic survey, yearling and older alewife were relatively well distributed throughout the lake, but we still saw the highest catches in the northern portion of the lake, similar to 2023. In the fall bottom trawl, or the fall forage, catch was very low, with the exception of one tow approaching 40 kilograms per hectare near Sturgeon Bay, and some notably higher catchers near the Manistique transect. Note the difference in results from this fall bottom trawl and the spring bottom trawl, where most of the alewife were actually widely distributed and highest in the central portion of the southern basin, where we actually saw very, very few during our extended survey this fall. Moving on to lake-wide estimates of yearling and older alewife biomass density. Here we have the entire time series back to the beginning of the bottom trawl in 1973, with the fall bottom trawl in black, the acoustic survey in blue in the dotted line, and the spring survey results from 2022 and 2024, again those years where we had full lake surveys, shown in red. This will be the standard representation of our surveys through the remaining slides. Overall, biomass density for yearling and older alewife, as estimated by the acoustic survey, was 4.7 kilograms per hectare and 0.68 kilograms per hectare in the fall bottom trawl. Now we can see that both estimates are still well below the values reported in the 1970s and early 80s, but when we zoom in, we can see a few more important details. First, we can see that the hydroacoustic survey had the second highest value in its time series in 2024, second only to 2023. However, this value is quite a bit lower than last year, and it is in line with previous values since 2004 for overall biomass for alewife. Secondly, we still see this discrepancy between the fall bottom trawl survey and the hydroacoustic survey, so that continues since the 2015 survey year. Next, we also note that the estimate from the spring bottom trawl is about double that of the fall. However, those error bars are overlapping, and we still don't see that spring bottom trawl survey high enough to overlap with the hydroacoustic survey. So it doesn't necessarily appear that sampling in the spring is shifting the needle in terms of overall biomass estimates for yearling and older alewife. Now moving on to age 0 alewife, which are estimated in our hydroacoustic survey. Following a particularly high year class in 2023, we still saw above average values in 2024, with about 510 fish per hectare, with the long-term average being 486 fish prior to this year. And this actually makes it the third highest estimate since 2012, and the second consecutive above average estimate for age 0 alewife. Now, similar to 2023, the highest densities we estimated by the hydroacoustic survey were in the northwest region of Lake Michigan. So again, it does appear that 2024 produced a modest or at least average year class for alewife. So digging a little bit deeper into our age data and making some comparisons across the 3 surveys from 2024, we've got alewife density at age on the left here and proportionate age on the right, with density at age on a log scale. Spring bottom trawl is shown in black, acoustic survey in gray, and the fall bottom trawl in blue. So there's a few interesting things to note. In 2024, density at age in our spring bottom trawl actually closely aligned with the acoustic estimate, which were well above the fall bottom trawl survey. This pattern was actually also observed in 2022 and fits our understanding that the fall survey underestimates the age 1 year class, while that doesn't appear to be the case in the spring when alewife are aggregated in deep waters. This result, that the spring bottom trawl produces reliable estimates for year class strength, is actually also observed on Lake Ontario and used in their management decisions. And they've been implementing the spring bottom trawl annually for several years. However, we see that for older age classes, ages 2 through 4 and even 5, both bottom trawl surveys produce lower biomass density estimates than the hydroacoustic survey by about an order of magnitude. It's still unclear why this is occurring, but we saw a similar pattern in 2022, albeit to a lesser degree as biomass overall was lower. So while yearling estimates are more aligned between the hydroacoustic and bottom trawl if we sample in the spring, we don't see that pattern hold for older age classes, which drives those lower biomass density estimates that we've observed in recent years. And finally, we still see very few older fish across the surveys. Age 6 and older are only present in very small numbers in the spring survey and absent from the other two. And this is really indicative of high mortality and continued age truncation in the alewife population overall. Now let's switch gears and talk about the other species that are also sampled in all three of our surveys, starting with bloater. And first we're looking here at yearling and older bloater, or those that are greater than 120 millimeters in length. And these still remain well below historic highs in the 80s and 90s across all three of our surveys. When we zoom in the last 2 decades, we see a few interesting points. First, the hydroacoustic survey continues to show this increase in trend since 2011 in total biomass, with this year's estimate about 5.2 kilograms per hectare. Now, we don't see this trend clearly in the bottom trawl, and in fact, this year's survey had one of the lower density estimates in recent years from the fall bottom trawl survey. Now, this disagreement or apparent discrepancy between these surveys is actually not the norm. In 7 of the past 10 seasons where we had both data sets, there was overlap within the error bars. We also know that the spring biomass estimate, again shown in red in 2024, was more than double what we observed in the fall of about 1.8 kilograms per hectare, but the standard error bars still overlapped. Looking at less than 120 millimeter bloater, which could be a reflection of year class strength, we saw 456 fish per hectare in the hydroacoustic survey, the second highest in the time series. However, only 16 fish per hectare were recording in the bottom trawl. Now, unlike the older bloater or the larger bloater, this discrepancy between the surveys is not uncommon, and the acoustic survey would indicate that this was an above average recruitment year for bloater. Moving on to the last species that's indexed by all three surveys, rainbow smelt. For yearling and older, or greater than or equal to 90 millimeter rainbow smelt, all three surveys continued to show relatively low densities compared to historic values, with less than 0.2 kilograms per hectare estimated in each one. So not much change in the adult population of rainbow smelt as estimated by our surveys, and these estimates still remain quite low. For small rainbow smelt, or those less than 90 millimeters, again, potentially indexing year class strength, we saw a relatively high number in the bottom trawl survey of 142 fish per hectare. This was the highest value in 7 years in the fall bottom trawl, but it was largely collected from 2 shallow water tows along the Manistee transect. The hydroacoustic survey recorded very few small rainbow smelt. Now, while the bottom trawl survey index could be interpreted as a relatively modest recruitment event this year, similar estimates in the fall bottom trawl with high standard errors have been observed in the last 2 decades, and there's been little apparent impact on a lake-wide adult population of rainbow smelt, given these sort of sporadic recruitment events. Let's consider overall biomass of forage fishes collected in our 2 surveys, starting with the fall bottom trawl, shown here in the top figure. So here we have total biomass for the 7 species of interest in the fall forage assessment, which was estimated at 2.1 kilograms per hectare in 2024, the lowest value since 2020, and 69% lower than the average from 2004 to 2023. In addition to the species we've already discussed, very little change from 2023 in terms of biomass density for other forage fishes. For example, 9-spine stickleback, slimy sculpin, and round goby biomass density was all 0.1 kilograms per hectare or less in the 2024 fall forage assessment, marking near lows for this time series. Deepwater sculpin was estimated at 0.26 kilograms per hectare, which makes 14 of the past 15 years with less than 1 kilogram per hectare estimated biomass density. On the other hand, the hydroacoustic survey biomass estimate, shown here on the bottom figure, was 77% higher than the long-term average dating back to 2004, with about equal representation of alewife and bloater within this survey. So this comes a year after the highest density estimate recorded in the modern survey, but we note that the total biomass of 10.8 kilograms per hectare this year is still much lower than historic acoustic estimates that were above 60 kilograms per hectare observed in the 80s and 90s, and that are still well below similar values observed in the fall bottom trawl survey during those years as well. Before closing today, I also wanted to quickly touch on age 0 perch, which have historically been indexed by the bottom trawl to track potential recruitment events. Not much to say here, except that this is the 14th year in a row where we haven't seen any indication of a strong recruitment event for the species. Summarizing the results from 2024, we can say that preyfish biomass is still well below historic estimates, with predominantly alewife and bloater making up a large proportion of that biomass. Evidence of a slightly above average recruitment event occurred in 2024 for alewife, and this is the second consecutive year of above average hydroacoustic estimates for the age 0 alewife in Lake Michigan. However, we're still seeing evidence of high alewife mortality and age truncation within the population, likely from heavy predation. Finally, the spring bottom trawl does appear to have higher catchability of yearling alewife than the fall bottom trawl, but we're still not seeing these very high density estimates that align with the hydroacoustic surveys by sampling in the spring. And this is really because sampling in the spring hasn't shifted the needle for sampling ages 2 through 5 within the alewife population. In terms of plans for 2025, we have an annual report prepared and ready for you today that includes a synthesis of the spring bottom trawl results from this season and comparisons to previous years. We do not plan to implement a spring bottom trawl in 2025. The spring survey could provide an additional year class strength index, but there really wasn't that strong evidence of higher alewife catchability, so this has been lowered in priority by the Lake Michigan Committee. We are exploring our options for 2026, and there has been some discussion on getting back to one of the other goals we originally had for spring sampling, which is some sort of a whitefish and cisco focus, potentially on younger age 1 or even age 2 fish. And finally, we do have a Lake Michigan CSMI 2025 year planned. Now, plans are up in the air for our summer sampling, but some of our spring sampling events are currently going on right now. And this includes comprehensive sampling of larval fish, starting with corriganines in the early spring. And with that, I'll just say thank you for listening, and everyone take care.